Hai, Assalamualaikum warahmatullahi ta'ala wabarakatuh. Alright, so this is chapter 3, which is numerical methods. So basically in numerical methods, you will learn a few methods where consists of the first one, roots of nonlinear equation, method of interpolation polynomial, and also method to solve the differentiation and also integration, and also the method for solving the ordinary differential equation and also partial differential equation. So you can see that the method is actually quite similar with the previous method that you have learned before, where you are familiar with the term with differentiation, integration, ordinary differential equation, and also partial differential equation. So the difference is previously you learn to solve the differentiation and also the integration as well as ODE and also PDE by using analytical method. Okay, let me write here. You use analytical method previously. Okay, analytical method, where in this by using analytical method, you use a specific formula or specific method to solve the problem such as differentiation, also integration, and the solution obtained is an exact solution. Okay, however, if you use numerical methods, okay, numerical method, the solution is just an approximate solution. Okay, but don't worry, even though it's just an approximate solution, it's still acceptable in certain cases, where such as if let's say you have a problem that is difficult to solve by using analytical method. Alright, for the first topic today that we're going to focus today is the roots of nonlinear equation. Right. So what is the method under the roots of nonlinear equation? There are three methods actually, where this method that you're going to learn is the method that you are going to use to solve the nonlinear equation. Okay, you're going to solve the nonlinear equation, and your purpose is to know the solution of x so that your fx is equal to 0. Remember, your purpose is to find the value of x so that when you substitute into the nonlinear equation, you will get equal to 0. So what is nonlinear equation, class? So these are the example of nonlinear equation where if you see here, it's quite difficult to solve uh, by manually or by using analytical solution, by using analytical method. So here we're going to use the method consists of bisection method, Newton-Raphson method, and also secant method to solve the nonlinear equation. Remember, our method, our objective is to find the value of x. Okay, and after you substitute into fx, you get equal to 0. In order to learn these three methods, you have to understand the intermediate value theorem, because all these three methods are basically based on this theorem. Alright, so let me introduce you what is intermediate value theorem. So basically, intermediate value theorem is defined as follows. If fx continuous in AB, alright, we have this figure number 1. You have a function of fx here, okay, which is continuous, okay, between A and B. Okay, it's continuous between interval A and B, where FA and FB is less than 0, which is FA and FB have different sign. When you substitute the point A into the fx, you get FA, right? And when you substitute B into fx, you get FB. And you can see here FA and FB have different sign. FA is a positive, FB is a negative. So when you multiply f and fb, you will get less than 0. So when you get this kind of condition, fa and fb have different sign, so you can say that there exists at least a solution in between the interval a and b, or you actually find the solution of the fx. When you substitute into f, you will get 0. So you can see here there are three solutions consist in this interval a and b. You can see these are the solution. First, 1, 2, and 3. Okay, so you have to understand intermediate value theorem. It says that when fx is continuous in AB and FB and FB less than 0, or FA and FB have different sign, then there exists at least a solution between A and B. Alright. Alright, let's look at one example for intermediate value theorem. So find the possible subinterval that contain the solution of fx equal to x cubed over 3 minus x squared plus 1 in the interval negative 2, 3 with step size h equal to 1. Right, you can see here the question actually wants you to find another interval between in the interval negative 2 to 3, okay, where the interval contain the solution for the fx. Okay, so you are given the step size here, which is denoted as h. And another thing is, you can see here the question asked you to use 4 decimal points. So you have to follow this, okay? Please don't use less than 4 decimal point. You can use more than 4 decimal point, but please don't less than 4. Otherwise, your solution will be, your answer will be quite different with the solution given in the question. All right. Another thing is, I want you to watch this YouTube video. Okay, this YouTube video teach you how to use your calculator, and it will help you to increase the speed when you're going to obtain the value. Okay, where you just plug in the function of fx into your calculator, and you will apply CALC in your calculator to just call the value. Okay, so it will be help you a lot. All right, let us focus on how to find the interval. First thing is, you have to come up with the table of x, fx, and also sine of fx. Alright, so what is the value in the column x? So this is actually the interval, negative 2 to 3 given in the question. Okay, this is actually the interval given in the question, negative 2 to 3, with the step size is 1. So negative 2, negative 1, 0 until 3. So how to obtain the fx? By just substitute each value of x into the fx given in the question. Okay, for example, you substitute negative 2, you will get negative 5.6667. You can see here I use 4 decimal places, 1, 2, 3, 4. 4 decimal places because I follow the question. Alright, so find the fx for each value of x, and then you can see here the sign for the fx, where here is negative, this is also negative, this is positive, positive, negative, and positive. So we come out in this column, and by applying intermediate value theorem, okay, intermediate value theorem, where intermediate value theorem said when fa and fb have different sign or less than 0, fa multiple fb is less than 0, or fa and fb have different sign, then there exists at least a solution between the interval. So you can see here where is the different sign. You can see this is negative and this is positive, so means that different sign. So there exists one in solution between the interval negative 1 and 0, and then this is positive, also here is positive, so no, and here is positive, negative, yes. So another interval between 1 and 2, 1 and 2 here, and then this is also different, negative and positive. Therefore, another solution exists in this interval 2 and 3. So from the big interval negative 2 and 3 given in the question, you have another three subinterval that contain the solution of fx, which is negative 1, 0, which is the interval is negative 1 and negative 1 to 0, 1 to 2, and also 2 to 3. So if you use the bisection, secant, and also Newton-Raphson method, you will find the solution between these three intervals. Alright, I think this is clear. Okay, we will continue in another video for the method of bisection and also Newton-Raphson and also secant method. Thank you. Assalamualaikum.